Cybercab might be the weirdest car Tesla has ever made. Clearly, it's making big progress. And the numbers are ramping up pretty fast since mass production is expected to start right at the beginning of April. The spotlight is even starting to overshadow the Model Y and Model 3. But the strange thing is, people still don't really believe that the Tesla Cybercab will actually be up and running anytime soon. So far, there's still a lot of debate about the design and the safety of this vehicle. Honestly, we can't even remember how many times Elon Musk has explained that Cybercab won't have side mirrors when it officially goes into operation. The Cybercabs with mirrors that people have spotted are mostly test prototypes that still need to go through trials. The official production version of Cybercab was revealed last week, giving us a closer look at the interior and some of the features inside the vehicle. Elon Musk also just confirmed that Tesla's Terafab project will be unveiled next week. You can think of it as a massive next-generation gigafactory dedicated specifically to producing AI chips, the brain behind the Tesla Cybercab Robotaxi. Let's get into the details now. Okay, so the truth is, a lot of people actually misunderstand what Tesla Robotaxi really means. We want to make it clear that a Tesla Robotaxi doesn't necessarily have to be a Cybercab. The term robotaxi basically refers to any vehicle that can drive itself fully and operate as a taxi without a human driver, like Waymo robotaxis or Uber robotaxis. Yeah, in that sense, many different vehicles could become robotaxis, such as the Model Y, Model 3, or Cybercab, as long as they're equipped with full self-driving technology. Meanwhile, the Tesla Cybercab is a vehicle that was designed from the ground up specifically to be a robotaxi. It doesn't have a steering wheel, it doesn't have pedals, and it uses automatically opening wing-style doors that can open and close on their own. In other words, Cybercab is a specific product, while robotaxi is a broader concept describing a type of vehicle. So to avoid confusion, it's best to clearly separate these two ideas. Right now, the Tesla Cybercab, along with full self-driving technology, is starting to feel more and more real. We're clearly seeing more of these vehicles out on the streets of Austin. It feels like we've moved past the stage where it was just a concept car. Instead, more and more details are popping up that show Cybercab is actually a product Tesla is getting ready to manufacture, deploy, and put into real-world use. Production is expected to start in April, so hopefully everything is still on track. Recently, we've been seeing a steady stream of new information about the Cybercab's interior design, the hardware currently being tested, increasing vehicle transport and testing activity, and accessibility features which are especially important for public transportation. All of these signals suggest that Tesla is seriously preparing to roll out Cybercab in the real world. Something you might not know is that the Tesla Cybercab uses polyurethane body panels, with the color molded directly into the material during the manufacturing process. That means Tesla doesn't need a traditional paint shop for production. According to Lars, Tesla's vice president of vehicle engineering, when it comes to repairs, damaged panels can simply be replaced. Recently, a Tesla Cybercab prototype was also spotted with a larger front camera, interior lighting, and several other new features. Yeah, images shared by David Moss on X show that the camera cluster behind the windshield has been significantly upgraded. This detail quickly sparked a lot of speculation in the tech community that Tesla might be testing a new hardware package for its full self-driving system, possibly even laying the groundwork for the future AI-5 generation. Even though the AI-5 computer isn't expected to enter mass production until around mid-2027, the larger lenses in the new camera cluster suggest Tesla may be upgrading its optical sensing system. These improvements are likely aimed at achieving higher accuracy and better environmental awareness, something that's especially critical for vehicles like the Cybercab that don't have a steering wheel or pedals, where the entire driving process relies completely on the autonomous system. Yeah. Some of the photos also show larger lenses and small separators between each of the front-facing cameras. Unlike Waymo, which relies heavily on LiDAR, cameras are basically the lifeline of the Cybercab. The larger front cameras are just one part of a broader hardware upgrade. Images from what's believed to be the official production version also reveal a very large cabin camera, along with another camera placed inside the trunk area. This new rear sensor is most likely designed to check and make sure passengers don't leave any belongings behind after a self-driving trip ends. It may sound like a small detail, but it's actually very important for a fully autonomous robotaxi system, where the vehicle has to monitor the cabin condition on its own after each ride, without any help from a human driver, and it doesn't stop there. Tesla has also refined the Cybercab's interior to improve durability and handle heavy, high-frequency use, something that's crucial for a vehicle designed specifically for robotaxi service. The storage compartment that was carpeted in the original concept has now been replaced with a hard, non-carpeted material, making it much easier to clean and better suited for constant use by different passengers throughout the day. On top of that, the window controls and USB-C ports appear to have been moved to the area just below the 21-inch central touchscreen. However, on the Cybercab that was displayed at the U.S. Department of Transportation headquarters earlier this week, the window controls were placed closer to the cup holder area on the center console. That suggests Tesla is still fine-tuning the interior layout. Overall, the Cybercab's cabin still sticks to an extremely minimalist design philosophy. There's basically just a single emergency stop button located above the center screen, and interestingly, that button also includes Braille text to ensure accessibility for all passengers. Inside the cabin, Tesla has also added a detail that brings a bit more luxury compared to its usual ultra-practical minimalist style, thin ambient lighting strips running along the door frames. In the latest images, these strips emit a soft blue glow, giving the interior a modern and refined feel. And the lighting isn't just for looks. It also serves a practical purpose by illuminating the door area when passengers get in or out of the car at night. It's a small detail, but an important one for a 24/7 autonomous ride-hailing service, where passenger experience and safety have to be maintained in all conditions. Beyond the upgraded camera system and interior changes, Cybercab prototypes that appear closer to the production version have also revealed several notable hardware improvements, further reinforcing the vehicle's positioning as a premium robotaxi optimized for continuous operation. One of the most notable highlights is the asymmetric wheel setup. The Cybercab appears to use larger and wider rear tires than the front ones, a configuration commonly seen on high-performance vehicles to better handle the high torque produced by electric drivetrains. Specifically, the front uses 215/60 R18 tires, while the rear is equipped with larger 225/60 R21 tires, which helps improve traction and power delivery during acceleration. The entire wheel system is fitted with Continental A-contact tires, combined with sleek, modern aerodynamic wheel covers. This setup not only gives the car a clean, refined look, but also helps reduce air resistance, improve energy efficiency, and optimize stability while driving. From what we've learned, Tesla has also equipped the vehicle with a high-pressure cleaning system for all exterior cameras. This ensures that the FSD hardware always has a clear view, even in rain or dusty conditions, without requiring human intervention. Although some of the early test vehicles spotted at Giga Texas still have mirrors and steering wheels, that's mainly to comply with local regulations during testing. The ultimate goal is still a completely wire-free experience, no steering wheel and no side mirrors. So if you see a Cybercab prototype with mirrors or a steering wheel, don't be surprised. That's just part of the testing phase. As the production timeline gets closer, these small but important hardware tweaks show that Tesla is really focusing on the reliability of its self-driving vision system. The Cybercab mass production assembly line is expected to start running in just a few weeks. Meanwhile, Tesla is preparing to enter a major turning point with the Terafab project, a massive semiconductor manufacturing initiative developed in-house by the company. Just recently, Elon Musk posted on X that Terafab project launches in 7 days. That means the project is expected to officially kick off on March 21, 2026. For those who may not realize just how huge this project is, Terafab is essentially a terascale version that goes far beyond the scale of Tesla's familiar gigafactories. The goal is to build a gigantic AI chip manufacturing facility in the United States, capable of producing hundreds of billions of chips every year. Some estimates suggest more than 100 billion, possibly even up to 200 billion chips annually. The factory is expected to integrate the entire process in one place, from AI chip logic design and memory production to advanced packaging, allowing Tesla to achieve full vertical integration in the semiconductor industry. The main driving force behind Terafab is Tesla's rapidly growing demand for AI chips. The company is developing several generations of custom chips such as AI5, which is expected to enter mass production around 2027, followed by AI6, AI7, and beyond. These chips will power full self-driving systems on millions of electric vehicles. The humanoid robot Optimus, with a goal of producing millions of units per year. The Dojo supercomputer used for large-scale AI training and other computing needs across the Tesla, XAI, and SpaceX ecosystem. Elon Musk has repeatedly emphasized that existing suppliers like TSMC, Samsung, or Micron may struggle to meet the enormous chip demand Tesla expects in the near future. In shareholder meetings and interviews, he has also warned that the semiconductor industry is facing serious bottlenecks, especially shortages of power, transformers, and cooling systems for AI data centers. issues that could last for the next 9 to 12 months. Building Terafab would allow Tesla to take control of its chip supply, reduce geopolitical and global supply chain risks, and accelerate domestic semiconductor manufacturing in the United States. From an analytical perspective, the project could cost tens of billions of dollars. Some estimates put it at around $25 billion, and it carries significant risk due to the technical complexity and long construction timeline. However, if successful, Terafab could transform Tesla from primarily an automaker into a fully integrated AI and semiconductor technology company, similar in scope to companies like Intel or Samsung, while strengthening its leadership in the global AI and robotics race. Building the facility in the U.S. could also create thousands of high-quality jobs and reduce dependence on overseas chip foundries. In 7 days, Tesla may mark the official launch phase of the project, which could involve starting construction, beginning detailed engineering design, testing small-scale prototypes, or announcing the specific location and partners involved, rather than immediate mass production. Even so, it's a strong signal that Tesla is seriously moving forward with the gigantic chip fab vision that Musk has been talking about since the beginning of the year. Coming back to Tesla's Robotaxi, if in the past Tesla's main competitor in the Robotaxi space was just Waymo, now a new strong rival has entered the race, one that Elon Musk definitely can't ignore. Lucid Motors, the EV company best known for its luxury air sedan and industry-leading battery efficiency, has officially joined the Robotaxi race by unveiling a concept called Lunar at its Investor Day event in New York on the 12th. Lunar is a fully autonomous two-seater vehicle with no steering wheel and no pedals, built on the company's upcoming mid-size platform. With its minimalist design and spacious interior focused on passenger comfort, the vehicle has a very futuristic look, and it's clearly aimed directly at Tesla's Cybercab. According to Lucid, Lunar is designed to achieve an impressive energy efficiency of about 5.5 to 6.0 miles per kilowatt-hour, significantly higher than many current competitors. The company also claims the vehicle can add more than 200 miles of range in just 15 minutes of fast charging, while reducing operating costs per mile by up to 40% compared to traditional ride-hailing solutions. These numbers are meant not only to improve the economics of ride-hailing services, but also to highlight Lucid's hardware advantages, especially its battery technology and the new Atlas drivetrain system, which the company promotes as continuing to lead in energy efficiency. Lunar itself isn't meant to be a standalone product. Instead, it's meant to showcase the potential of Lucid's upcoming mid-size platform. That platform will eventually produce 3 consumer vehicles, 2 SUVs called Cosmos and Earth, along with a third model that hasn't been named yet. Lucid also emphasized that the mid-size platform is designed to support both autonomous and commercial applications. The company says it is currently in advanced negotiations with Uber to deploy vehicles based on this platform at large scale, similar to its earlier Gravity Robotaxi program. This suggests that Lucid isn't just stopping at copying the Cybercab design, but is trying to build a broader ecosystem that combines affordable personal vehicles with autonomous fleet services. However, the gap between concept and reality remains very large. Lucid has clarified that Lunar is currently only a concept, with no concrete production development underway. CEO Mark Winterhoff initially said the company was working on the vehicle, but the company later confirmed to media outlets that it has not launched any production projects specifically for a robotaxi. Meanwhile, Tesla has demonstrated tangible progress with its own robotaxi network. Community reaction has largely leaned towards skepticism about Lucid. Many posts and comments mock Lunar as a CGI copy of Cybercab, lacking real self-driving software. Some opinions point out that creating a hardware concept is relatively easy, but achieving autonomy at scale is the real challenge. An area where Tesla has taken the lead with full self-driving, operating in more than 10 cities, and supported by billions of miles of real-world driving data. Lucid is well known for battery performance. The Lucid Air once held the record for the longest driving range, but when it comes to autonomous software, we believe the company still has significant weaknesses. In a wide-ranging interview at the 2026 Prosperity Summit, Tesla CEO Elon Musk shared an ambitious vision for the future of artificial intelligence, robotics, and the global economy. His remarks did not only focus on Tesla's latest technological progress, but also outlined a broader picture of how AI and robots could transform the way humans produce, work, and even how society functions in the future. The biggest highlight of the interview was an update on Tesla's Optimus humanoid robot program. Elon Musk said the company is entering the final stage of development for the 3rd generation of Optimus, known as Optimus 3. According to him, when it launches, it will be the most advanced robot in the world. Tesla plans to begin low-rate pilot production this summer to refine manufacturing processes and test the system. If everything goes according to plan, mass production could begin in the summer of 2027. Notably, Tesla is preparing about 10 million square feet of factory space dedicated solely to robot production, highlighting the company's extremely ambitious plans in this field. Although the growing use of robots often raises concerns about job losses, Elon Musk emphasized that Tesla has no plans to lay off employees as it deploys the Tesla Optimus robot. Instead, he believes robots will play a supportive role for humans, helping boost productivity to unprecedented levels. As robots take over physically demanding, repetitive, or dangerous tasks, humans can focus on more creative and higher-value managerial work. According to Musk, the combination of humans and robots could allow productivity per Tesla employee to reach extremely high levels, beyond physical robots. Musk also spent considerable time discussing the rapid development of the artificial intelligence industry. He believes the AI sector is now entering a powerful expansion phase, with progress happening faster than ever before. One important milestone he predicts is the emergence of fully automated recursive self-improvement, a situation in which AI models can train themselves, improve themselves, and generate better versions of their own systems without human intervention. Musk believes this process could become fully automated by the end of this year or, at the latest, sometime next year. He also mentioned the latest AI model from xAI called Grok 4.2. According to Musk, it is currently the best model in the world at predicting outcomes across a wide range of fields. However, he also openly admitted that xAI is still trailing some competitors when it comes to programming capabilities. Yeah. CEO Tesla even revealed that he arrived late to the interview because he had been leading a large-scale programming meeting aimed at accelerating improvements in that area. He expects xAI to catch up with competitors in coding capabilities by around the middle of this year. From the progress in robotics and AI, Musk offered a bold prediction about the future of the global economy. He argued that once humanoid robots can produce goods and provide services at a pace far exceeding the growth of the money supply, the cost of living could fall dramatically. This could usher in an era of large-scale deflation, where goods and services become extremely cheap and widely accessible. In that context, Musk believes society could move toward a model of universal high income, where people enjoy a good standard of living without the intense competition for resources seen today. Musk even suggested that, in the distant future, money itself might no longer play the central role it does today. He imagines governments could simply distribute money to citizens because the output generated by AI and robots would be sufficient to meet the needs of society as a whole. In such a post-scarcity economy, Musk believes superintelligent AI systems would not care about currency at all, focusing instead on physical factors such as energy, computing power, and the ability to move and transform matter. We might have been looking at the Tesla Semi the wrong way. It's not a burden. It could actually be Tesla's flagship product in the years ahead. Elon Musk has called the Tesla Semi a money machine many times, because it's the electric truck with the lowest energy consumption per mile. We bet you'd be hard-pressed to find another truck that costs only about 15 cents per mile to run. That's why Elon Musk is confident that, in the future, freight companies could actually lose money if they don't switch to electric trucks like Semi. For years, that claim was met with plenty of skepticism in the trucking industry. After all, traditional trucking has relied on diesel engines for decades, and many people believed electric trucks couldn't compete on cost, durability, or long-haul capability. But recent real-world testing is starting to show that Tesla's CEO may not have been exaggerating at all. So just how efficient and how insanely cost-effective is the Tesla Semi? The clearest proof comes from a real-world pilot program conducted by the logistics company Moan Transport in Texas. In this program, the Tesla Semi wasn't tested in a lab or under tightly controlled ideal conditions. Instead, it was put to work exactly the way a commercial truck would be used every day, hauling real cargo, driving long routes, and operating continuously within the company's logistics network. Over the course of the trial, the truck logged more than 4,700 miles. What's remarkable is that the results actually exceeded Tesla's original expectations. So what happened? According to data released by Moan Transport, the Tesla Semi achieved an average energy consumption of just about 1.64 kilowatt-hours per mile. That's extremely impressive, considering Tesla originally targeted around 1.7 kilowatt-hours per mile for the truck. In other words, in real-world operation, the vehicle actually performed better than what the manufacturer promised. But what really caught the trucking industry's attention isn't just the energy efficiency. It's the operating cost that comes from that electricity usage. In Texas, The average commercial electricity price is currently around 9.12 cents per kilowatt hour. Multiply that by 1.64 kilowatt hours per mile, and the energy cost to run a Tesla Semi comes out to roughly 15 cents per mile. That number might sound small, but in the trucking business, where each truck can drive hundreds of thousands of miles per year, a difference of just a few dozen cents per mile can completely reshape a company's cost structure. To really see the difference, we need to compare it with traditional diesel trucks, which still dominate the global freight industry. A typical Class 8 diesel truck usually gets about 6 to 7 miles per gallon. If we take an average of 6.5 miles per gallon and combine it with the average diesel price in the Gulf Coast region of about $3.11 per gallon, the fuel cost for a diesel truck comes out to roughly 48 cents per mile. Put those numbers side by side and the gap becomes obvious. Tesla Semi about 15 cents per mile, and a diesel truck nearly 48 cents per mile. So what does that actually mean? Okay, it means the energy cost of the Tesla Semi is nearly 70% lower than a traditional diesel truck. In the logistics industry, that's an enormous gap. A long-haul truck can easily drive around 100,000 miles per year. If it runs on diesel at roughly 48 cents per mile, a company would spend close to $48,000 per year on fuel alone. But if that same truck were a Tesla Semi, running at about 15 cents per mile, the electricity cost for the same distance would be only around $15,000. That means each truck could save about $33,000 every single year. When you scale that up to an entire fleet, the economic advantage becomes even clearer. A transportation company operating 100 long-haul trucks could save more than $3 million per year just from lower energy costs. Over the lifetime of a truck, typically 10 years or more, the total savings could reach tens of millions of dollars. Yeah, that's why when Elon Musk calls the Tesla Semi a money machine, he's not just talking about technology or performance. He's talking about a completely new economic model for the trucking industry. And the benefits don't stop at fuel costs. The Tesla Semi also has the potential to significantly reduce maintenance expenses. Traditional diesel trucks contain a huge number of complex mechanical components: multi-gear transmissions, exhaust after-treatment systems, fuel pumps, turbochargers, and many other moving parts. All of these require regular maintenance and can fail after long periods of use. By contrast, an electric drivetrain is much simpler, with far fewer moving parts. That means less wear and tear, a lower chance of mechanical failure, and significantly reduced maintenance costs over time. There's also another major advantage. We mean energy price stability. You know, diesel prices on the global market can swing wildly due to geopolitical tensions. For example, conflicts involving the US and Iran, and you already know how tense those situations can get. Sorry, we won't go too deep into it here, but the bottom line is that fuel prices are likely to become even more volatile in the future. Electricity, on the other hand, tends to be much more stable, especially when companies can sign long-term power purchase agreements. That allows trucking companies to predict their operating costs more accurately and plan their finances with far greater confidence. Okay, the operating cost numbers are clearly the strongest proof that the Tesla Semi could truly be a money machine. But what is it actually like for the driver inside the truck? Is the experience really as good as Tesla claims in the trucking industry? Economic efficiency is crucial, but driver experience matters just as much. A truck might be extremely cost-efficient, but if it leaves drivers exhausted, is difficult to use, or lacks comfort, it's unlikely to be adopted at scale by transportation companies. Earlier versions of the Tesla Semi still had a few shortcomings. That's why, with the release of the newer version, Tesla introduced a series of notable upgrades inside the cabin, aiming to optimize the workspace for long-haul truck drivers. In the earlier prototype, the Tesla Semi already attracted attention by replacing the traditional instrument cluster with two 15-inch displays. But in the new production version, Tesla has upgraded those screens to 16 inches, giving drivers more display space and better visibility. These two screens act as the central control hub for the entire truck. All critical information from speed, energy levels, trip data, and navigation to safety alerts is displayed in real time on a digital interface. This creates a major difference compared to traditional diesel trucks, where the dashboard still mostly relies on analog gauges and small information displays. Inside the Tesla Semi, almost the entire driving experience is fully digital, much like the approach Tesla has used in its electric cars for years. Not only does this make it easier for drivers to monitor the vehicle's condition, but the large screen system also allows Tesla to push software updates remotely, adding new features or improving the interface over time. In other words, The truck starts to feel less like a traditional freight vehicle and more like a modern piece of technology on wheels, along with the new display system. Tesla has also significantly upgraded surrounding visibility by equipping the truck with a network of up to 10 cameras. In the world of heavy-duty trucks, visibility is one of the most critical challenges. These massive vehicles, often stretching dozens of meters in length, tend to have multiple dangerous blind spots, especially when maneuvering in tight spaces like seaports, warehouses, or crowded logistics hubs. The new camera system on the Tesla Semi creates a near 360-degree view around the truck. All the video feeds from these cameras are displayed directly on the two large screens inside the cabin, allowing the driver to monitor every area around the vehicle with just a quick glance. Compared to traditional designs that rely heavily on large side mirrors, the camera system provides a wider field of view, significantly reduces blind spots, and works seamlessly with advanced safety features. More importantly, this system also serves as a key foundation for advanced driver assistance systems and potentially even autonomous driving technology, something Elon Musk has mentioned many times before. In Tesla's long-term vision, cameras essentially act as the eyes of the vehicle, helping it recognize its surroundings and respond more intelligently to what's happening on the road. Another notable upgrade inside the cabin is the addition of a driver attention monitoring camera. This technology is becoming increasingly common in modern vehicles, especially those equipped with advanced driver assistance systems. The camera tracks the driver's eye movement and level of attention, ensuring that the driver remains focused on the road while assistance systems are active. If the system detects that the driver is distracted or looking away from the road for too long, it can immediately issue a warning. This helps improve safety while still allowing drivers to benefit from the truck's advanced driving technologies. This addition shows that Tesla is moving toward a new operating model, where automation technology and human oversight work side by side to improve overall safety. In the long-haul trucking industry, where drivers often spend hours behind the wheel without a break, monitoring driver alertness can significantly reduce the risk of accidents. Beyond the high-tech upgrades, Tesla has also paid attention to smaller but extremely practical details for drivers. One of those improvements is the redesigned side window of the cabin. In the earlier prototype, the window design was highly aerodynamic, but some drivers worried it might not be very practical in everyday situations. In real-world trucking, drivers frequently need to interact directly with workers at warehouse gates, toll booths, or loading docks. The new window design allows drivers to easily reach their arm outside when necessary, improving convenience while still maintaining the cabin's modern look. Tesla has also relocated the cup holders inside the cabin. It might sound like a tiny change, but for drivers who spend long hours behind the wheel, small ergonomic tweaks can make a big difference. In the previous version, the cup holders were positioned fairly low, forcing drivers to lean down to grab their drink. In the new version, the cup holders have been moved higher and closer to the control area, allowing drivers to grab a drink more easily without taking their eyes off the road for too long. The storage space inside the cabin has also been expanded. Yeah, the Tesla Semi already has a fairly unique layout, with the driver's seat positioned in the center and two walkways on either side, which creates a more spacious feel compared to many traditional trucks. In the updated version, Tesla has made better use of this space by adding larger storage compartments near the cup holder area. This gives drivers extra room to store essentials like phones, notebooks, tablets, or other electronic devices they rely on during daily work. Finally, Tesla has also integrated wireless phone charging directly into the cabin, in an era where smartphones have become an essential work tool for many drivers. From communicating with dispatchers and tracking routes to managing delivery schedules, having built-in wireless charging eliminates messy cables and ensures drivers' phones stay powered throughout the trip. We've seen a lot of comments claiming that Tesla will never be able to compete with the big truck manufacturers because the Tesla Semi supposedly can't operate in Europe, a massive tractor truck market that generates huge profits. Okay, to be fair, for many years Tesla has focused mainly on the North American market, where highways are long, freight infrastructure is spacious, and trucking regulations are relatively flexible. And to be even more honest, even in the US, Tesla is still behind many competitors in terms of adoption within the trucking industry. The simple reason is production volume. The number of Tesla semis built so far is still very small. To date, the total number of semis produced hasn't even reached 1,000 units yet. But last week, we got our first real look at Tesla's mass production line for the Semi, and it looks both impressive and large in scale. Tesla plans to start ramping up semi-production this year, and Elon Musk has confirmed that the company is also considering bringing the Tesla Semi to Europe and possibly even manufacturing the truck in Germany. That idea alone immediately challenges the long-held assumption that the Tesla Semi will only operate in North America. According to the plan Elon Musk mentioned, the Tesla Semi could appear in the European market as early as next year, if everything goes smoothly, as usual. That announcement quickly sparked a lot of discussion across the trucking industry. Europe is one of the largest and most competitive truck markets in the world, dominated for decades by long-established manufacturers. Companies like Volvo Trucks, Daimler Truck, Mercedes-Benz and DAF Trucks already have powerful manufacturing networks, distribution channels, and after-sales service systems across the region. In fact, over the past few years, many European manufacturers have also begun launching their own electric trucks as part of the transition toward zero-emission transportation. That means if Tesla truly wants to bring the Tesla Semi to Europe, it will face a far more intense competitive environment than it does in the US. However, producing the Tesla Semi in Berlin actually makes a lot of sense. Instead of exporting trucks from the US to Europe, building them at Gigafactory Berlin-Brandenburg would help Tesla reduce shipping costs, avoid tariff barriers, and most importantly, adapt the truck's design to European infrastructure and regulations. Because in reality, the trucking environment in Europe is very different from the United States. In the US, heavy-duty trucks typically use a long-nose design, where the front of the truck extends forward. This allows the engine to sit in front of the cabin, making maintenance easier and giving drivers a larger, more spacious cabin. On top of that, US regulations usually limit the length of the trailer, while the tractor itself isn't restricted as strictly. This gives manufacturers much more freedom when designing the truck's front end and overall layout. Meanwhile, in the European Union, truck size regulations are much stricter, especially when it comes to the total length of the tractor and trailer combination, which is capped at a fixed limit. Because of this, most European trucks use a cab-over design, meaning the cabin sits directly above the front axle instead of having a long front nose. This layout helps maximize the allowed vehicle length so that more space can be dedicated to cargo. This fundamental difference is exactly why the Tesla Semi, with its distinctive long-nose American truck design, could face challenges if it wants to operate in Europe without major adjustments. Beyond overall length, the truck's size also needs to be reconsidered to fit European roads, which are often narrower and filled with more roundabouts, unlike the long, straight highways commonly found in the United States. Based on technical data analysis, the Tesla Semi currently has a wheelbase of roughly 200 to 230 inches. Depending on the battery configuration, that size works well for US operating conditions, but it could become problematic when navigating the tight roundabouts commonly found in European cities. Because of that, if Tesla truly wants to manufacture the Tesla Semi in Berlin, the company may need to redesign the truck's chassis, potentially shortening the wheelbase to around 150 inches. And yeah, that's not a simple task. The Tesla Semi's massive battery pack occupies a large portion of the space under the chassis, so shrinking the frame while maintaining a large battery capacity would require entirely new engineering solutions. Another factor frequently mentioned by industry experts is the driver sleeper cabin. The current Tesla Semi is primarily designed as a day cab, meaning the cabin is intended for daytime driving and does not include a sleeping compartment behind the seats. In Europe, however, driver working hour regulations are much stricter. Truck drivers are typically allowed to drive a maximum of about 9 hours per day, followed by at least 11 hours of continuous rest. In practice, that makes a sleeper cab almost essential for long-haul trucks operating across Europe. If Tesla wants the Tesla Semi to truly compete with trucks from companies like Volvo Trucks or Mercedes-Benz Trucks in that market, the company may need to introduce a sleeper cab version specifically designed for Europe. With the Tesla Semi's overall height of around 13 feet, integrating a compact sleeping system behind the cabin is theoretically very possible. Some experts even suggest Tesla could design a smart fold-out bed system, transforming the cabin into a small but comfortable resting space, almost like a miniature mobile living space for the driver. However, bringing the Tesla Semi into production in Berlin would come with several significant challenges. We think the first issue is manufacturing infrastructure. So why do we think like that? Yeah, even though Tesla unveiled the Tesla Semi back in 2017, large-scale production in the United States is still ramping up. That means setting up an entirely new production line in Europe would require considerable time and investment. The second challenge involves battery supply. The Tesla Semi is believed to use a battery pack several times larger than the one in a Tesla Model 3. Producing batteries at scale in Europe is still facing difficulties, particularly due to high energy costs and strict environmental regulations. If Tesla ends up importing batteries from factories outside Europe, Transportation costs and import tariffs could drive up the overall price of the truck. And finally, one of the biggest challenges is charging infrastructure. The Tesla Semi is designed to use Tesla's megacharger system, which can deliver extremely high power levels over 1 megawatt. To deploy this charging network across Europe, Tesla would need to coordinate with multiple countries and significantly upgrade existing power grids. That's not a simple task, especially at a time when many European countries are already facing increasing pressure on their energy systems. Do you think Tesla can overcome these challenges to bring the Semi to Europe? Drop a comment below. Forget Donut Lab. Forget their solid-state batteries. Stop paying attention to a company full of gimmicks like that. We already have a far more reliable solid-state battery. 400 watt-hours per kilogram energy density, delivering up to 1,500 kilometers or 932 miles, with safety reportedly improved by over 70%. More importantly, this company plans to begin testing solid-state battery installations in vehicles before Q3 2026. We know you may not believe it, but this is what was announced on stage by Changan Automobile. We regret discovering them so late. They deserve far more attention. Changan Automobile is one of China's big four automakers, with an extensive product portfolio spanning multiple sub-brands that cover everything from affordable cars to luxury electric vehicles. What brought them onto our radar, however, is their solid-state battery, arguably the best available today, and potentially the biggest breakthrough in history. It's not an exaggeration to say the entire world will be eager to get its hands on this battery, and it will be a slap in the face to Donut Lab. Solid-state batteries have long been considered the holy grail of battery technology. There are many reasons, but the simplest is that they address nearly all the fundamental weaknesses of traditional lithium-ion batteries. Instead of using flammable liquid electrolytes, solid-state batteries use solid electrolyte materials, significantly reducing the risk of fire while enabling more favorable electrochemical reactions. This structural shift allows solid-state batteries to achieve much higher energy density, meaning that with the same battery weight, a vehicle can travel much farther. This is the single most critical factor in the EV race, where driving range remains the biggest concern for users. Changan Automobile claims its Golden Bell solid-state battery reaches an energy density of up to 400 watt-hours per kilogram. If accurate, this figure would send shockwaves across the entire industry. For comparison, most current EV batteries fall in the 150 to 250 watt-hours per kilogram range. Clearly, many of us have become fixated on what's called energy density whenever a new battery technology is announced. A typical example is Donut Lab's solid-state battery. It made a splash with claims of 400 watt-hours per kilogram energy density, 100,000 cycles, and 5-minute charging. However, so far, none of the tests have revealed much, and the only thing we really know is that they have a strong marketing strategy, keeping people skeptical, interested, and curious by releasing a new test video every 2 weeks, which eventually becomes tiresome. So until they can prove the claimed 400 watt-hours per kilogram energy density, we'll take a closer look later for now. Let's set them aside. By contrast, when you hear about a battery technology coming from China, it tends to feel far more credible, because frankly, they usually deliver on what they claim. With Changan's Golden Bell battery, they even held a dedicated event where the 400 watt-hours per kilogram figure was clearly displayed on screen. Even the most advanced battery technologies today rarely exceed 300 watt-hours per kilogram. That means Changan's battery could nearly double the current standard in terms of energy density. It's no surprise, then, that the company claims its vehicles can achieve a range of over 1,500 kilometers CLTC on a single charge. This specification has been officially announced on stage. Of course, the 1,500 kilometer figure may be theoretical or measured under ideal conditions. But even if it drops to a more realistic range, say around 1,000 to 1,200 kilometers, it would still represent a massive leap forward. It wouldn't just eliminate range anxiety, it would bring electric vehicles closer to, or even beyond, internal combustion engine cars in terms of convenience. Long road trips through remote areas, where charging infrastructure is still limited, would no longer be a major concern. Beyond performance, the Golden Bell battery is also designed with intelligence in mind. By 2026, integrating artificial intelligence into batteries is no longer far-fetched. Changan's battery is said to support remote diagnostics, real-time performance monitoring, and predictive failure detection before issues even occur. This effectively transforms the battery from a passive component into an active system capable of taking care of itself. In addition, the company claims a safety improvement of up to 70% compared to conventional batteries. thanks to the elimination of flammable liquid electrolytes, one of the primary causes of EV fire incidents. To better understand just how groundbreaking Chang'an's solid-state battery is, it helps to place it in the context of today's battery technologies. First, there's LFP battery, widely used by companies like BYD and even Tesla on some of its models. As mentioned before, LFP's biggest advantages are low cost, high safety, and long lifespan. However, its main drawback has always been relatively low energy density, typically around 150 to 180 watt-hours per kilogram. This means vehicles using LFP batteries either have shorter driving ranges or must rely on larger, heavier battery packs to compensate. Compared to LFP, Chang'an's solid-state battery is almost superior across the board. With an energy density of 400 watt-hours per kilogram, it could deliver double or even more the driving range without increasing battery size. This not only makes vehicles lighter but also improves overall performance, from acceleration to energy efficiency. Next is nickel-manganese cobalt battery, commonly used in higher-end vehicles due to its higher energy density, typically around 200 to 300 watt-hours per kilogram. However, NMC comes with higher costs, relies on scarce materials like cobalt, and carries greater safety risks compared to LFP. While NMC has long been considered the pinnacle of lithium-ion battery technology, it still falls short of what Chang'an's solid-state battery is claiming. If NMC represents the peak of the current generation, then solid-state batteries clearly belong to an entirely new generation. Looking at the Tesla 4680 battery, considered a major leap forward for Tesla. It's also primarily an improvement within the traditional lithium-ion framework. The 4680 battery optimizes cell design, reduces costs, and increases efficiency, but fundamentally remains unchanged in terms of technology. Don't misunderstand. We mean the 4680 battery is still good with an energy density of nearly 300 watt-hours per kilogram. The only issue is that it's not as powerful as solid-state batteries. However, the biggest question remains, can Chang'an actually deliver on its promises? The history of the technology industry is full of promises that far exceed reality. But it's noteworthy that China has repeatedly demonstrated its ability to commercialize technology quickly. CATL and BYD not only developed the technology, but also deployed it on a large scale in a very short time. If Chang'an can do the same with solid-state batteries, the competitive advantage they create will be enormous. In this context, Western automakers like Ford Motor Company and General Motors will face immense pressure. They could continue developing their own technology, but that would take time. Or they might be forced to cooperate with Chinese companies to avoid being left behind. Either way, the balance of power in the electric vehicle industry is clearly shifting. And it's not just about solid-state batteries. While this video mainly focuses on Chang'an's Golden Bell solid-state battery, there's another type of battery they're developing in partnership with CATL. And this one opens up a completely different path compared to solid-state technology. It may not be as powerful as solid-state batteries, but it carries significant implications for more affordable vehicles. While most of the world is still focused on lithium, yes, we've become heavily dependent on it, with volatile pricing and growing pressure to find alternatives. Sodium-ion batteries are steadily emerging. We've all heard about them, to the point of fatigue, but it's clear that many people still don't fully realize just how advanced China's sodium-ion technology has become. Sodium is incredibly abundant, found almost everywhere, even in seawater. This immediately addresses one of the EV industry's biggest challenges: cost and supply chains. If lithium is the white gold of the new energy era, then sodium is more like salt, cheap, widely available, and virtually inexhaustible. That's why when Chang'an Automobile and CATL announced the new Naxtra sodium battery, it drew serious attention. Its energy density is around 175 watt-hours per kilogram, significantly lower than solid-state batteries or even some high-end lithium-ion packs, but that's not the main point. What makes the Naxtra battery special lies elsewhere: cost, durability, and performance under extreme conditions. One of its biggest advantages is its ability to operate in extremely low temperatures. According to reports, the Naxtra battery can discharge at temperatures as low as -50 degrees Celsius while maintaining stable performance. This is a massive advantage, especially for countries with cold climates or high-altitude regions where lithium-ion batteries often struggle. In such conditions, lithium batteries can lose a significant portion of their capacity and charge much more slowly, but sodium largely overcomes this issue. In addition, the Naxtra battery offers a driving range of over 248 miles. That may not sound impressive compared to solid-state batteries, but it's more than reasonable for the mass market segment. In reality, most EV users don't need more than 600 miles. A vehicle capable of 186 to 248 miles per charge is already sufficient for daily use and even short trips. What matters more is affordability and low operating costs. And this is exactly where sodium batteries could outperform lithium. Without relying on expensive materials like lithium, nickel, or cobalt, production costs could be significantly lower, potentially even in some projections. If that becomes reality, it could unlock EV adoption on an unprecedented scale. Affordable electric cars, possibly even cheaper than gasoline vehicles, would no longer be a distant vision. What's particularly interesting is that Changan Automobile isn't just researching this technology. They already have concrete deployment plans. The Changan Nivo Q05 and Changan Nivo A06 are expected to be the first models equipped with Naxtra batteries. This shows that the technology is no longer confined to labs or concept stages. It's rapidly approaching real-world consumers. Compared to solid-state batteries, sodium batteries may not be as flashy. They don't promise 1,500 kilometers of range or 400 watt-hours per kilogram energy density. But from a practical perspective, they might be even more important. Because technology doesn't just need to be the best, it needs to be the most suitable for the majority. And sodium batteries check all the right boxes: affordable, durable, safe, and capable of performing well across a wide range of environmental conditions. When you place sodium batteries alongside current technologies, the differences become even clearer. Compared to LFP, already considered a low-cost and safe option, sodium batteries could be even cheaper, while also being far less affected by low temperatures. Compared to NMC, they clearly fall behind in energy density, but outperform in cost and sustainability. And compared to solid-state batteries, sodium batteries are more of a practical solution, whereas solid-state represents the optimal solution. What's important is that these two paths don't cancel each other out. In fact, they can coexist and serve different segments of the market. Solid-state batteries will likely be reserved for premium vehicles and long-range applications, where performance is the top priority. Meanwhile, sodium batteries are better suited for mass-market cars, urban vehicles, or even large-scale energy storage systems. Of course, as we dug deeper into this type of battery, we realized that the story of sodium-ion technology is not a sudden breakthrough, but rather a grueling relay race spanning more than 4 decades, one in which scientific dreams were long overshadowed by the towering presence of its sibling, lithium-ion. To understand why it took so many years, we have to rewind to the 1970 and 1980 when scientists first began to recognize the potential of storing energy in electrochemical cells. At that time, sodium and lithium stood on roughly equal footing in theory. However, fate took a different turn when lithium-ion batteries demonstrated superior energy density and greater compatibility with the electrode materials available at the time. As a result, the world's financial and intellectual resources poured into optimizing lithium to power the mobile device revolution. For the next 2 decades, sodium batteries were left behind in dusty laboratories. Labeled as the loser due to a fundamental physical barrier, sodium ions are about 25% larger than lithium ions, making it extremely difficult for them to fit into the crystal structures of electrode materials, like trying to stuff a soccer ball into a compartment designed for tennis balls. This mismatch led to rapid structural degradation after only a few charge-discharge cycles, resulting in very short lifespans and virtually no commercial viability for early sodium batteries. The challenges went beyond size. Sodium's higher atomic weight and lower electrochemical potential meant it was often seen as heavier and weaker. Unable to compete in a world where phones were getting thinner and electric vehicles needed longer range, the real turning point came when materials scientists discovered the key to taming sodium atoms by developing hard carbon structures for the anode, replacing graphite, which performs poorly with sodium. Finding a suitable storage material required enormous trial and error, consuming thousands of experimental hours to create pathways wide enough for sodium ions to move without collapsing the entire crystal lattice. At the same time, advances in transition metal oxides and Prussian blue analogs for the cathode helped sodium batteries gradually close the performance gap. Yet even as the technology made significant progress, the biggest barrier remained economics of scale. With lithium supply chains already highly optimized and cost-effective due to mass production, building new infrastructure for sodium was a risky gamble that few companies were willing to take. Everything began to change when the global electric vehicle boom surged in the early 2020, driving lithium prices sky high and raising concerns about resource scarcity. This forced energy giants to reconsider the virtually limitless supply of sodium derived from seawater. The current rise of sodium-ion batteries is the result of three converging factors: bottlenecks in the lithium supply chain, breakthroughs in nanomaterial science to handle larger ions, and the urgent need for renewable energy storage systems that prioritize safety and affordability over ultra-high energy density. It is a journey from obscurity into the spotlight, proving that in science, an idea never truly dies, it simply waits for the right moment. When both technology and economic conditions have matured, to assert its value on the global energy stage. This is an incredibly smart strategy from Chang'an Automobile. Instead of betting on a single technology, they are developing multiple pathways in parallel. Collaboration with CATL is also a key factor. CATL is currently the world's largest battery manufacturer, with production experience and scale that few companies can match. When a company like this enters the sodium battery space, it almost guarantees that the technology can be commercialized quickly and at scale. This is no longer a small-scale experiment, it's a true industrial strategy. Looking more broadly, sodium batteries could have an impact not only on the electric vehicle industry, but across the entire energy ecosystem. With their low cost and high durability, they are well suited for renewable energy storage such as solar and wind power. This is especially important as the world transitions toward clean energy. An affordable and long-lasting battery system could help solve the storage problem, one of the biggest barriers to renewable energy adoption. Of course, sodium batteries still have their limitations. Lower energy density means vehicles either need larger battery packs or must accept shorter driving ranges. However, with continuous improvements, this gap can gradually be narrowed. More importantly, in many use cases, this drawback is not a major issue. The key point here is that not every revolution comes from creating the best solution. Sometimes, what changes the world is something that is good enough but cheaper, more accessible, and scalable. Sodium batteries may be exactly that kind of innovation. Batteries are not just a component of EVs, they are the foundation of an entirely new ecosystem. From transportation and energy storage to solar and wind power, whoever controls battery technology holds a decisive advantage in shaping the energy economy of the 21st century. And at this moment, China is moving very close to that position, not by copying, but through innovation, optimization, and most importantly, deployment at a scale that the rest of the world struggles to match. Chang'an's solid-state batteries represent the pinnacle of performance, where electric vehicles can travel farther, operate more safely, and break through current limitations. Meanwhile, sodium batteries carry a deeper significance. They democratize technology, turning electric vehicles from a premium product into something accessible to hundreds of millions of people. One represents the future of performance, the other, the future of scale, and China is pursuing both at the same time. This raises a major question for the rest of the world. Will they compete, collaborate, or be left behind? Technologies like LFP, NMC, and even innovations such as Tesla's 4680 battery are still highly important. But they are clearly no longer the final destination. The game has changed, and so have the rules. In the end, the story is no longer about who copies whom. Instead, it's about who is leading. China is showing that it is not just participating in the race, but rewriting how the race itself is run. If this trend continues, the world may have to get used to a new reality. The future of global energy may not be shaped in Silicon Valley or Europe, but very likely is being built in China.